Alright guys, so here is our first lecture video since we've started all this stuff online. Just to recap, what's really nice about the videos is that you guys are able to pause and replay anything that you might have missed or you need more time to write down. So please keep that in mind as we're moving forward. It might seem like I'm going very quickly, but that pause button is right there. Pause it, do what you need to do, then hit play. Rewind it a little bit if you miss something, use that to your advantage. So for our first video lecture, we have section 8.3, Show A Quadrilateral is a Parallelogram, and it's going to use all those properties we talked about in 8.2. Alright, so I made this little list here. Hopefully you guys can read it okay. Just to recap our 5 properties of parallelograms. First one was the definition, opposite sides are parallel. Second one was one of our theorems, opposite sides are also congruent. Opposite angles are congruent. Our consecutive angles or our same side angles are supplementary, which means they add to be 180 degrees. And last but not least, our diagonals bisect each other. And basically, today, for the most part, other than one theorem we learned today, we're going to use the converse of all of these. And converse just kind of flips the order, which means we're just going to kind of flip our thinking. Before, we used these facts and theorems to just solve for x, find missing numbers, find missing angles, all of that. Today, we're going to use the converse of these theorems to say, okay, because this is true, we know it's a parallelogram. And that's kind of our thinking with this section here. So you'll see a lot of the examples today, like 2 or 3 of them are just kind of like you just have to think about it and it's more explaining and less math. And then we have our mathy examples too. So let's just go ahead and get started and dive right into this. Like always, first up we have some theorems that we're going to use. Our first theorem, take a look at it with me here. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you think back to it, up to our list, we already knew that. We're just kind of flipping our thinking here. All right, so showing that we have 2 pairs of opposite sides congruent is enough to say it's a parallelogram. And very similarly, if both pairs of opposite angles are congruent, then it's enough to say it's a parallelogram. Same idea, using these 2 theorems right here. We're just taking the converse of it and saying, okay, if we show this, we know it's a parallelogram. All right, so it's a little bit more showing and proving and less just solving. So let's take a look at our first example here. We have a real world type application problem. So we have an amusement park ride, has a moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes over the top and around in a circular motion. In the diagram below, AD and BC represent the 2 swinging arms, and they don't change length. They're 16 feet. They stay 16 feet, so they're congruent. And then DC is parallel to the ground. So we know that this base right here, DC, is parallel to line L right there. We know that. They told us that. We can draw in our little arrows. We're good to go. They want us to explain why the moving platform AB, so why is the actual seats of the ride always parallel to the ground, line L. So our first little bit of reasoning here is, okay, we're working with parallelograms, so let's show ABCD is a parallelogram. Even though it's swinging and the angles inside are changing, these lengths right here will always be the same. No matter what angle this is at, as it's going around and around and around, no matter what angle this is at, those lengths are never changing. And since we have 2 pairs of opposite sides congruent, we could say that ABCD is a parallelogram. And we know that if it is a parallelogram, we know that opposite sides are also parallel. So we know that AB is parallel to DC and AD is parallel to BC. Well, if we know that AB is parallel to DC, and we also know that DC is parallel to line L from the problem, that's what they told us up here, we have this thing called transitive property of parallel lines. We learned back in chapter 3 saying that if this line is parallel to that line and that line is parallel to this line, that top line is also parallel to the bottom line, just kind of skipping the middleman. We could say that AB is parallel to line L, which is what we wanted to show. So this is an example of just one of those thinking ones. So you just kind of have to think about it, kind of put your thoughts on paper, put it in order. Excuse me. A little easier to do as a class with examples, and then like homework will be more solving heavy, but that's kind of where our logic is at for this section. So let's go ahead and see if we can apply this logic to this next example that's a little bit more math heavy. So we have quadrilateral WXYZ, and they gave us 3 of the 4 angle measures. The first thing I'm going to say is, okay, quadrilateral, we know n is going to equal 4. It has 4 sides. That quad right here tells me 4 sides. So I know, using that formula we learned in the very first section of chapter 8, that n minus 2 times 180, where n is just the number of sides, I know that all these angles are going to have to equal 360 degrees when we add them all up together. So to give myself a little visual here, I can go ahead and just kind of draw in quadrilateral. It doesn't have to be perfect. X, Y, Z. It's important that I stay in order when I'm labeling my angles here. It doesn't matter which one I start at or which way I turn, counterclockwise or clockwise. I just have to stay in order. W, X, Y, Z. Fill in what they give me. W is 42 degrees. X is 138. Y is 42. And they want me to find angle Z. Well, I know they're all going to add to be 360. So if I do 360 minus 42 minus 138 minus 42, I end up with 138 degrees, meaning measure of angle Z is 138 degrees, which means our opposite angles are in fact congruent. So because both pairs of opposite angles are congruent, WXYZ is a parallelogram. And that's more of a math heavy type problem you're more likely to see, kind of a balance between the two. But it's just using those theorems to say, okay, then what does it have to be a parallelogram type of thing. So we're going to keep moving forward. Again, pause if you need more time to take things in, but we're going to keep moving forward to our second set of theorems. And this first one is just a little bit different. This is kind of like the newer theorem for today. And it says if one pair of opposite sides of a quadrilateral are congruent and parallel, that's the big thing right there, congruent and parallel, then the quadrilateral is a parallelogram. So showing that one pair of opposite sides is congruent and parallel, that's enough to say it's a parallelogram. And we're going to be using that in an example here shortly. And then our next theorem is if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. And that's very similar to the other theorems we've learned already, so I won't touch on that quite as much. But let's see how these work in examples. So example 2, identify the parallelogram. The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV equals TU. So basically, SV is congruent to TU, is what that's saying. Well, looking at our picture, they tell us that ST is congruent to VU with these little tick marks right here. And with these little arrows, if you can kind of see them there, this one's a little bit harder to see. They have the little arrows there. We also know that ST is parallel to VU. So then going back up to this top theorem up here, we've shown that one pair of opposite sides are congruent and parallel. Therefore, STUV is a parallelogram, which then we conclude saying, well, since it's a parallelogram, we know opposite sides are congruent, so SV would equal TU. Because we know opposite sides of a parallel are congruent. And that's how we can use this top theorem that was a little bit newer today. That's how we can use that top one. Just show one pair of sides is congruent and parallel. Then you can go and use all the other theorems for a parallelogram. So let's see one with a little bit more math involved. Again, this is a very common type of question for you to be asked. And we actually really like this type of question here. For what value of x is quadrilateral CDEF a parallelogram? Well, looking at it, they gave us our diagonals, and we know that diagonals in a parallelogram need to bisect each other, meaning it cuts it in half. It cuts into two equal pieces. So to figure out what value of x I need, I just got to set these guys equal to each other. I just got to say 5x minus 8 equals 3x and solve for x. So I could subtract the 5x to keep things balanced here to get negative 8 equals negative 2x. And then I could divide by negative 2 to get x alone, telling me that x has to equal 4 in order for CDEF to be a parallelogram. And this is the most commonly typed question that you get asked. It's the most straightforward, and you'll see it the most often for sure, especially in my class. So let's go ahead and try a few on your own. Why don't you guys go ahead and pause the video and try these guided practice ones on your own. And then when you're done, hit play and you can see me work them out. But this will be a good little self-check here because we're kind of reaching the end of the lesson to see if you kind of get what's going on, see if you remember the theorems. Let's go ahead and pause, try this on your own. Okay, so let's see how we did. What theorems can you use to show a quadrilateral is a parallelogram? Well, looking at this here, I see that opposite sides are both congruent. And they're also parallel. That's what that little red triangle tells me. So since I know opposite side congruent and parallel, that's how I know that's a parallelogram. And that's kind of all I'm looking for, is what's the theorem. Just kind of write it out like this. If you have the numbers, you can use the numbers. But I would just write it out like this, a little short sentence using abbreviations. So then like for number 3, they gave us all 4 sides. So we know both pairs of opposite sides are congruent, which means that's a parallelogram. And very similarly, we got our angles over here, so we know both pairs of opposite angles are congruent. So that guy right there is also parallelogram. So that's just kind of restating the theorems, knowing the theorems, again, working on that more logic thinking side of it, and less exactly math computation heavy. For number 5 down here, for what value of x is quadrilateral MNPQ a parallelogram, well, that's kind of like the last example we just did. They gave us our diagonals, and we know diagonals bisect each other. That's kind of our explanation. So we could say that 2x equals 10 minus 3x. So to solve this, I can add my 3x to get 5x equals 10, divide by 5 to get that x equals 2. And that's kind of all I would have to do for this. So hopefully you guys checked your work, see how you did okay. Remember, always email me with any questions. We're going to keep moving forward though. Let's keep the video nice and short. We have one more example to do that's just a little bit harder, so make sure you guys are following along, paying attention. Last example here for this section. Show the quadrilateral ABCD is a parallelogram. And they gave us this guy over here with our little coordinates, ordered pairs you can see. Whenever we're given a coordinate geometry problem like this, we're going to want to use the theorem that says one pair of opposite sides is congruent and parallel. So we're going to want to show AB is congruent to DC and AB is also parallel to DC. So to start to show they're congruent, we want to use the distance formula. So just a little refresher, our distance formula is going to be distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. That's my distance formula here. So we know that AB is going to equal -3 minus 2 squared plus 3 minus 5 squared to get, well, this is -3 minus 2 is -5 squared. 3 minus 5 is plus -2 squared, which we know is going to be 25 plus 4, or square root of 29. And we're just going to leave it as a square root of 29. No point in messing with decimals here. We're just trying to see that they're the same. So then to find DC now, we're going to do the same thing, just with two different points. 0 minus 5 squared plus 0 minus 2 squared. It's going to be -5 squared plus -2 squared. We're looking pretty good to get 25 plus 4. Whoop. Got the square root of 29 again, so they are congruent. Check that off my list. That part's done. Now, to see if they're parallel, we're going to want to use our slope formula. And we know our slope formula is y equals y2 minus y1 over x2 minus x1. It's a little bit easier. Less square roots, no squaring. So to find the slope of AB, I got 5 minus 3 over 2 minus -3. 5 minus 3 gives me 2. 2 minus -3 is like 2 plus 3. So it gives me 5. So I have a slope of 2/5. And then to find the slope of DC, I got 2 minus 0 over 5 minus 0. Oh look, 2 minus 0 is 2. 5 minus 0 is 5. So they are congruent and parallel because they have the same slope. So since one pair of opposite sides are both congruent and parallel, ABCD is a parallelogram. And that's the hard. All right, that's one of our more in-depth type problems. You got to know your stuff. So you guys don't need to expect a ton of those, but you could expect maybe one. Maybe I would expect you guys to know what you would need to do to get started at this point for sure. But that's a little bit harder. We're going to stick more into the type of problems like we saw in the last guided practice. But yeah, there's that last example there. So to wrap things up, there's this nice chart for you that has all the theorems in one place. So this is on page 519 in your textbook. And it's just a nice little list of all these theorems. So if you haven't been taking very detailed notes the past few weeks, I guess, since we started chapter 8, I would highly, highly, highly recommend pausing the video, going to your textbook, and writing this down so you have it somewhere easy to see, because we are going to have quizzes in the future, and since it's all online, it is open note, so it'll be nice to have all these theorems in one place. So again, make sure you take note of this chart right here, because it makes everything nice and easy to read, gives you a picture, help you out in the future. But the last thing here to wrap this up is your homework assignment, which is going to be due Friday at 11:59 p.m. You can submit it via Google Classroom. Here's our CP assignment right here, page 520, numbers 4 through 6, 9, and then 19 through 21. Again, these are going to be a little bit more math heavy on that side because we did a lot of the thinking ones in class together. Just kind of get your logic in the right place. As always, feel free to email me with any questions, and have fun learning about parallelograms.